Well, I'm finally getting around to playing with this TPL5110, which is a little timer chip. And we're gonna have to put it onto a breadboard because I haven't designed a circuit. So it's gonna go on one of these adapter boards. And on the other side we've got, is it TSOP and then SO8, I guess? So we're gonna throw it in one of these, and it comes in a SOT23 package, which should still fit. Hopefully. It is kind of tiny. Have I got tweezers? No. I should probably get some. Right, found some tweezers. So let's get this little bugger open. Oh, for heaven's sake. There we go. Oh gosh, it's tiny. Can I come in any further? Heaven knows if it's in focus. Well, we're going to give it a go. We'll solder it onto one of these breakout boards. There, I think. Oh God. It looks tiny. Okay, well, we're going to put one pad on and then drag that onto it, I think. So hopefully I've got a heated soldering iron. It's a bit dark, isn't it? Not sure I can do much about that. So just one pad, the closest one. Is that actually going to match up? It is, isn't it? It's just not. I'm going to put some more solder on. Well, has that done it? Let's find out. No, that's at the wrong angle. So you can probably see it, but I can't really see it from here. But it looks like it's bridged a bit there, and this needs to come up a bit further. I'm doing it on the wrong side of the thing, aren't I? I don't know. Let's just double check. Let's try it on the other side. Hang on. No, that's not going to work out. I'm going to do it on this side and we'll just hope it works. No, that is not right, is it? That is, the pitch is just too far off. Right, this bit's going to have to get done sort of off camera, I think. Well, that is as good as it's going to get for this setup. It doesn't look too bad. All the pins are at least soldered. Ooh, God, it was a bit difficult to do, I have to say. Even just edging it into that position, not ideal. Got to choose some coloured pins here. God, that's come out a little bit. Choose some coloured pins, I think. I'm going to go for these weird, is that teal? I don't really know what colours are what, but it looks a bit like teal, so I need 4 for one side and 4 for the other. Actually, I'll tell you what, we'll go for a different colour for the other side. It'll help me distinguish pin 1 when I figure that out. So let's get this board out. Right, so the easiest way to solder these pins, at least in my experience, has been to pop it into a breadboard first. So let's do that. Now let's have a quick look and see if we can see where pin 1 would be. Well, it should be there, but I don't know that for certain. So I'll put these in and we'll just solder it and then we'll find out later. I don't know if anyone noticed, but I really like using flux and I didn't use any flux that time. Well, only what was in the solder already. I didn't use any extra flux. So this TPL5110 is a timer IC, and I'm going to be using it for a few projects, I think, but for the first one, I'm going to be looking at that low-powered ESP8266 temperature sensor that I was doing outdoors. So this is going to mean it's going to be it goes down to the nanoamps, this thing. So I'm excited to try it. It is Sunday, but I haven't been doing any lazy Sunday stuff. I've been out entertaining a 3-year-old, which is cool. I gave him one of these, I don't have it, I wish I'd showed it to you before. It's called a hex bug, and it's one of these little vibration motor things like people have on a toothbrush, and it sort of races around. It's very cool. Anyway, I've waffled and taken time doing this, so I'm going to go away and try this out. Need to find some MOSFETs and have a look at the datasheet. Okay, so this is the datasheet for the TPL5110 Nano Power System Timer for power gating. And so I can see here we've got power supply voltage 1.8 volts to 5.5. That's fine. I'm going to use it at 5, I think. I actually intend on using it with a lithium polymer battery in the end, so it will work in those ranges. But the battery cutoff, I'm going to have to figure that out. Current consumption at 2.5 volts, 3.35 nanoamps. Okay, I can't read down to nanoamps, not exactly, but I'll give it a go with my multimeter. I thought it was 100 nanoamps, but maybe it is at 5 volts and I've sort of forgotten. So selectable time intervals from 100 milliseconds to 7,200 seconds. What is that? Let's find out. oops. Divided by 60 is 120 minutes. So it's 2 hours. You can change that to. Timer accuracy is 1%, and it's a resistor selectable thing. And there's manual MOSFET. I'll show you that in a second. So applications, Internet of Things, battery powered systems, blah, blah, blah. We're in a SOT23 package. We already know that because we've just tried to solder it. And this is the schematic. Okay, so I'll have to figure out which way is, I have to look at the chip and identify pin 1. That shouldn't be too difficult, but we've got a fairly simple circuit here. There's our resistor that's adjusting our delay. So we could use a variable resistor. I'll see if I've got one in the right range. I might not. I might only have 10K ones. And then there's a button there on the delay, manual drive probably. So that probably means you press that, it turns it on. There's our MOSFET driver just here. So that's a P-Channel Mosfet. And enable /1 shot, not sure what that means. And then done to the microcontroller. Let's have a look at the... here we go. So these are pin descriptions. So VDD, supply voltage. I'm much more used to VCC. Ground. Delay M drive, so timer interval set and manual MOSFET power on. So you can put it on with a switch, that's good. Done. Logic is input for watchdog. So it says it's an input. I don't know if it's high or not. We'll check that. And drive is our output and enable is an input. Select mode of operation. When enable is high, the TPL works as a timer. When enable is low, the TPL runs on the MOSFET one time for the programmed time interval. The next power on of the MOSFET is enabled by manual power on. I see. Okay. So we're going to put that to high, I think. So we'll figure that. And anything else important here? Well, there's the timing. Okay. So how does that work? Done to drive delay. So minimum delay is 100 nanoseconds. Okay, so when it powers on, the minimum delay is 100 nanoseconds for done to signal that it's finished. And the maximum is T drive. So that is the time that it's the big time delay set by the resistor. So that's the maximum time it can be without a done signal, because it's going to expect to start it again, I guess. That makes sense. It's one of these current, supply current, here we are. So at 5 volts or 5.5, we've got the red line here. So we're looking about under 100 nanoamps. In fact, all the way up to 100 degrees, so under 100 nanoamps. That's incredible. Hang on, how is that different to this one? Oh, that's temperature, and this is, I see. Okay, cool. Now, an overview, detailed description. We don't need to know that. We sort of know how we're going to set it up, so we'll just sort of throw it together. But I was hoping it would tell me. Oh, please don't tell me there's a formula. Okay, resistance range 500 ohms to 170 kiloohms. So 500 ohms is going to be that very small 100 milliseconds, and the massive kiloohms range was going to be the 7,200. Hopefully I can get back to that section now. Uh-oh. He's lost it. Oh, there we go, 170 kiloohms. I was hoping there'd be a table. Oh, time intervals. Excellent. So resistance. Okay, so we probably want to go, let's try and go for like a 15 to 20 seconds. I think I can find a 15 or a 16 kilo ohm resistor, so we'll use one of those. I don't know what range it will be in though, because there seems to be very small amounts between 10 seconds and 20, so I'm not quite sure what that equates to. Okay, let's do it. Let's put it together. Wait, just before that happens, I think I'm going to need to program a microcontroller in order to do the done signal, because I'm no good at counting, so I'm not going to do the minimum maximum. So I'll get a microcontroller so it's powered by this thing. And I guess, I don't know, stick an LED on it, and put a delay in the code before it hits the done signal. So I'll give that a go. So here's my simplified schematic. So I've taken out the button. We might put it in, I'm not sure, but I've taken out the button for now, so this should just be a free running circuit. We're going to throw a microcontroller on there. So we've got our P-Channel Mosfet. We're going to be using an NDP6020P, and that's just because I have one available. I don't think it's the ideal one to use here, but it is compatible with 3.3 volt and 5 volt logic. And that's why I bought it, was for this temperature sensor thing that I was going to use. Anyway, this is the pin out. We've got VCC, ground, delay, done, drive. So that one drives our MOSFET into the gate, and then enable. Now, it might be worthwhile sticking a resistor on that P channel. We don't need to, but might be worthwhile. We're not going to, because we're just going to try it out. So let's get it hooked up. I'll leave the diagram on the screen as we do this. So what's first? Let's connect up power and ground, shall we? So power is the third pin on here because we don't have that one connected. So let's stick it in over here. So power, ground. Have I got the right colors? Probably not. I never have the right colors, but it turns out I do on this very odd occasion. And then what's next? We've got delay. So delay, I'm going to be using a resistor straight to ground. This is a 15k resistor, sorry, straight to ground. And then we also need, enable needs to go to 5 volts. I've run out of red, so let's go with green. Pop that into 5 volts. And we need to have our, let's get our MOSFET in. There we go. So this MOSFET, the NDP6020P, is gate, drain, source. I hope that's right. So our drive can be a blue one, straight into the gate, and then source is going to be positive, and the only long one I've got here is actually black, but we're going to be using that, so I'll throw that in. And then for our drive, we're going to be driving a microcontroller. Now I pre-programmed this one, as I explained, so we'll throw that in. So it's already got a program in there, it knows what to do. Going to be using a resistor, I think it's on pin 9 if I remember correctly, so I'll throw that in there. I've got the ink from that brown pen that I used to write this all in me, and And then we're just sticking it on this half of the rail. So the rails are split, so I'm just going to throw it in there and put that positive rail to ground. And what's next? The done pin. So that goes from here to pin 7, doesn't it? I think. Just like that. Now I need power and ground. So let's do that. Turn on the power supply. Good old noise that lots of you will understand. And then let's get that hooked up. So positive is blue in this case, and negative is black. And then I just need to hook this up and press start. Hopefully it's going to work straight away. Fingers crossed. And go. Let's give it a second. I forgot to stick the drain on, didn't I? So drain to 5 volts, and the microcontroller also needs to go to ground. So we'll use the yellow one. Well, that's clever. So it probably is working. I just didn't realize that I'd not connected up my microcontroller. So that's ground, and that is my 5 volt pin. So let's turn it on and off again. And fingers crossed, that works. Right, in order to check this, I'm going to stick a switch in so that we can trigger this ourselves. So let's pop one onto the drive pin, well, the delay / drive pin. And then the other side needs to go to power. Now let's try it. So I can hold that button down and drive the MOSFET. However, it's not working. I might need to, whoops, I've just thrown the switch out. I might need to hold that done pin down. Let's see if I need to do that. Right, so what I've done is I've added a resistor to the done pin to pull that down, and let's put the pin in pin 7 now. There we go. So what I'm guessing, I don't know, floating capacitance in the breadboard, who knows? I'm holding the done down with, what is that resistor? Let's find out what that resistor is. Hopefully it's something fairly high. Well, that's a 1 meg resistor I'm holding done down with. So essentially, we're on a breadboard, so there's a lot of crap going on, but also it's sort of unknown state of the pins on the microcontroller. So maybe it's best to pull it down so that it doesn't think it's finished. So single drive, LED comes on, not very bright, admittedly. And then after 5 seconds, I think it is, it goes off. Let's have a look at a scope, on the scope, and see what this is actually doing. Let's see what the time delay is. Oh, actually, before we do that, should we have a look at the current draw? Let's do that now. How am I going to do that? Right, we're over range, obviously, so let's we'll hold our probes together, and then we'll release them when we know it's on. So let's wait a second until we can see the LED come on. In fact, we can trigger it now. So we know it's on, so we'll just let it go off, and then we'll release, and we'll be able to see what the current draw is when it's idle. So we are looking at, that's not right, surely. 0.03 microamps. How much is that? Well, it's probably going to come on again now, so let's just connect these probes again. There we go, it's on again. I've got my probe shorted, and then it's off now, so let's release. 0.03 microamps. Let's just double check that. I will remove that connection. Turn it off and turn it on again. It just seems like it's too low. Zero that out and we'll try again. All right, I've got my probe shorted and it's off. Yeah, that looks like it's accurate. I mean, measuring those tiny currents is difficult anyway, so it's certainly not in the microamps range, so that's fairly good, isn't it? So yeah, maybe we are reading that low. Crazy. Okay, scope time. So get some probes and we'll stick our ground into ground, and then do you know what would be easier if we just read the voltage rather than do anything funny here? So we need another wire. That will do. So let's throw that into the drive pin of the MOSFET. Not the drive pin, sorry. The drain pin. Throw that over there. And let's auto set up that because I can't remember what I was doing last time. Stick our probe in the breadboard. Oh, these lights. Is it that one or is it this one? Hang on a minute. It's picking up a lot of noise from the lights, but I'm not sure what my, which way am I going? That way. It's all right. You can see all the noise from the lights there, can't you? But if we just go to 2 volts per division, because this is about 5 volts, so it'll be about 2.5 of these divisions. And what is our horizontal? Well, we need that to be, if we think that's about 15 seconds, should we go with 5 seconds per division? Yeah? Okay. So let's plug in power and ground. So there's power. And we'll just let it free run. And there's ground. So a little bit of a spike, it's come on, you can see it there. So let's see how long it stays on for. In fact, we can come in a little, can't we? So yeah, 2 seconds per division. We won't manually trigger it, we'll just let it go itself actually. So here we go, there's another one there. So it's on for, what, 7 seconds or something? So 2 seconds per division, it's on for about 6 seconds, and then it's off for 2, 3, 4, oh, quite a few. It might be too many actually for it to read properly on here. Okay, run stop. Let's measure that. So 1, 2, 3, 4, 5, 6, 7, 8, 16 seconds is our time delay with a, what was that, 15K? Is that what I said it was? Yeah, with a 15K resistor. So accuracy may vary there, but our on time is purely based on our microcontroller and what code we're putting it in. I'm not sure if you can actually see it, so let's zoom in, shall we? I hate using the scope when people are watching. It's very difficult to see that, but that's our on time, and then there's our off time is just here. And so that's the time it's using pretty much no current. So if you can imagine this was in deep sleep, the current would have been an awful lot more than what we saw there. And if you're dealing with a battery powered thing, then this little TPL5110 is really going to do the job, isn't it? Well, anyway, that is enough for now. I'm going to explore this thing a little bit more. But yeah, he's pretty cool, isn't he? I advise you all, if you can, to pick one up. I know there are some breakout boards that you can get these days, and and play with. But if you just want to buy one of the bare chips, get one of these breakout boards, then you can play with it yourself. Pretty fun. All right, I'll speak to you all again soon.